Here's problem 812. A 1.2 kilogram mass is projected from ground level with a velocity of 30 meters per second at some unknown angle above the horizontal. A short time after being projected, the mass barely clears a 16 meter tall fence. Disregard air resistance and assume the ground is level. What is the kinetic energy of the mass as it clears the fence? Alright, this is actually the best kind of problem to do with energy. If we have a projectile and its velocity at point A is 30 meters per second, so we are going to define our first point as point A, and then it proceeds through the air and then clears a fence. Height of the fence is 16 meters. So we'll say that that is point B when the projectile makes it to the fence. So at that point it's going to have some kind of velocity, v sub b, and it has a height. We're going to define our ground level as our zero height. Okay, so if we write down the one equation to rule them all, we have the kinetic energy at A plus potential energy at A plus any work done along the way equals kinetic energy at B plus the potential energy at B. In this case, we do have kinetic energy at A. So we have a 1/2 mass velocity at A squared. Our potential energy at A is actually going to be 0 because we define ground level, our lowest height, as being 0 height. And we have no springs involved, so there is no potential energy at A. Work done along the way, well, we said disregard air resistance, and there's no other forces along the way, so there is no work done along the way. Kinetic energy at B, well, that's what we want to find. So actually, let's just keep it in that form, kinetic energy at B. And then we do have potential energy at B. We have an mg height at B. No springs to worry about. So we're going to solve this for the kinetic energy at B. It's going to be equal to 1/2 mass, the velocity at A squared, minus mg height at B. So this is going to be 1/2 times 1.2. Velocity at A was 30 meters per second squared, minus 1.2 times 9.8 times 16 meters. So we get 352 joules. So that's the kinetic energy at point B. If we wanted to go further, we could figure out what its velocity is, but we just want to find the kinetic energy at point B. So it's 352 joules. Note that even though we reach some different heights along the way, we only need to select A and B. We only need to worry ourselves with 2 points, A and B, and not worry about what happened along the way in order to come up with this result. So it's pretty straightforward, nice result, 352 joules.